This is class notes page 33 and example 12 on braking load. A Dodge Caravan with a gross weight of 5,000 pounds is parked on a street with a slope of 9 degrees. Find the force required to keep the caravan from rolling down the hill. What is the force perpendicular to the hill? So you have to answer two questions on this. And so I'm going to draw out the diagram which relates to this. So here's my ground. And the angle of 9 degrees is going to be exaggerated a little bit. Okay, so here's my 9 degrees. Okay, I'm not going to make my car very fancy, right? So I'll just call this box a car. And so you end up having 3 different forces on a problem like this. The first one is the force that is due to gravity, force of gravity. So it's going to go down, and that is, it ends up to be perpendicular to the ground, right? So this is going to be my F1. So F1 is equal to the force of gravity, which is equivalent to the weight of the car. Okay, the next thing you have is the force perpendicular to the ramp. Okay, so I'm going to draw it out this way. And this one, the arrowhead, it goes up like this. Okay, so this is my F2. So F2 is equal to the force perpendicular to the ramp. And then my third one is F3, and that is the force required to keep the car from rolling down. Force required to keep the car from rolling down. Okay, so I'm going to represent that. It's going to be up here. So when it goes down, that is what makes it roll down. So then I'm going to make it so that it goes in the opposite direction. So it's going to go this way. Okay, so this green vector right here, this is my F3. I'll just say F3 here. Now remember that vectors are transferable, so that means that I can move this vector and I'm going to place it here. So it's going to work out so that if it's not going to roll down, then it's going to end up to be exactly touching the F3. So this is your, or F2, so this is your F3. And so this is going to create a right angle here. Okay, so once we have all of that, we're going to transfer some angles, right? So look at this triangle right here. And if this is a right angle and this is 9 degrees, that means that this up here has to be 81 degrees. And then we know that this is a right angle, right? That's perpendicular to the slope. So then this has to be 9 degrees. Okay, so after that, you can just focus on this particular triangle here. I'm just going to color it in yellow. Right, and then I'm just going to redraw this. Okay, so I'll just redraw this triangle and then put in all the different colors on this. So we have this one, which is our F1, and I'm going to call this as the magnitude because we're going to put the weight of the car in there. So that's going to be 5,000. And then you have the perpendicular to the ramp, that's this. So that's going to be your F2. And then your last one is your F3, which is the force required to keep the car from rolling down. Okay, so here's your F3. And here's my right angle. Okay, so we know that this right here is our 9 degrees. So from there, I could just use baby trig. So use baby trig. Okay, so I have, I need to put the magnitude symbol on this here. Okay, so using that, I have, this is 5,000, and this is 9 degrees, so I'll take the cosine of 9 degrees is equal to F2 divided by 5,000. So then cross multiply and solve for F2, and F2 comes out to 4,938.442, and the unit on that is pounds. And then the other one, to figure out what F3 is, I'll be using the sine ratio. So it's sine of 9 degrees, and that is equal to F3 divided by 5,000. So you get F3 to equal 782.172 pounds.